Have you ever looked at a number and just got this feeling that it's hiding something? That right under the surface, there's this incredible secret pattern just waiting for someone to find it? Well, today, we're going to pull back the curtain on one of the most elegant puzzles in all of mathematics, and it's all wrapped up inside one single amazing number. Okay, so here it is. Meet the star of our show today, 142857. Now, at first glance, it looks, well, pretty ordinary, right? But trust me, this number is a total mathematical celebrity. It holds a secret that is so simple but so mind-blowing it honestly feels like magic. Let's start putting it to the test and you'll see what I mean. All right, first up, let's multiply it by 1. And no surprises there, we get the exact same number back. This is our baseline, our starting point. From here on out, things are going to get a little weird. Okay, now watch this closely. When we multiply by 2, we get 285714. Now, take a look at those digits. Do they look familiar? They are the exact same digits we started with. They've just rotated. It's like the 1 and the 4 got bumped to the back of the line and everyone else just shifted up. Wild, right? So, let's keep this going. What about times 3? That gives us 428571. And there it is again. The same 6 digits just dancing around into new positions. It's like they're on a carousel, and with each multiplication, a new digit gets to right at the front. So, what happens if we multiply by 4? We get 571428. The pattern holds up perfectly. It's the same group of digits, just in another unique order. The consistency here is just absolutely incredible. All right, times 5 gives us 714285. This strange, beautiful, rotational thing just keeps on happening without fail. This is definitely not some random coincidence. What we're seeing here is a really deep mathematical property in action. And finally, let's try multiplying by 6. We get 857142. And that completes the set. We've gone through multipliers 1 all the way to 6, and every single time our number has just reshuffled its own digits in a perfect circular loop. This is just amazing, right? But it brings up the most important question of all. Why? Why this specific number? Is this just some random fluke? A 1 in a million party trick? Or is there a deeper mathematical reason behind this beautiful pattern?
Well, of course there's a reason, and it is fascinating. This kind of number actually has a name. It's called a cyclic number. And its secret origin story? It comes from a simple fraction, 1 divided by 7. If you pop that into a calculator, you get a repeating decimal, 0.142857, 142857, forever. Our magic number is that repeating part, so multiplying it is basically just like shifting the starting point within that infinite loop. But wait, there's actually another hidden layer of order here. Let's try something called the digital root. That's just the single digit you get when you keep adding up the digits of a number until you can't anymore. So let's take any of our results. How about 571428? If we add up all those digits, we get 27. Now add those up. 2 plus 7 gives you 9. Go ahead, try it with any of the other products. You'll see the digital root is always 9. A really great way to visualize all of this is to stop thinking of the digits in a straight line. Instead, picture them arranged on a wheel, just like this. Every time we multiply, we're just spinning that wheel to a new starting position. It's a perfect way to see how this sequence is locked into this predictable, unbreakable cycle. So, okay, this is a very cool property, a really beautiful piece of number theory, for sure. But you might be sitting there thinking, so what? Is this just a fascinating little curiosity? Or does this kind of pattern have any real importance out there in the world? Well, it turns out that these predictable, looping patterns are actually incredibly powerful. This is so much more than a party trick. It's a tool that gets used in some seriously advanced fields. Its behavior, predictable yet complex, is perfect for creating dynamic ciphers in cryptography, for spotting repeating patterns to compress data, and even for modeling quantum systems. Let's just zero in on that first one, cryptography. At its heart, cryptography is the art of writing and cracking codes to keep our communications safe and secure. And a clever repeating pattern can be a cryptographer's absolute best friend. Here's a really simple way to see it in action. Let's say we want to encrypt the word math. We can use one of the rotations of our number, say 2857, as a shifting key. So the first letter, M, we shift it by the first digit, 2, and it becomes O. The next letter, A, we shift by the next digit, 8, and it becomes I, and you get the idea. Because the key comes from a cycle, it isn't random, but it's also not static, which makes the code way harder for an outsider to break. But the real takeaway here, the big idea, is that this isn't just about abstract numbers and secret codes. This type of repeating, cyclical pattern is a fundamental concept that's literally woven into the fabric of our universe. It shows up everywhere, from our most cutting-edge technology to our most ancient forms of art.
Just look at this comparison. On one side, you have the pure logic of complex code, where these patterns create security and function, and on the other, you see the exact same principle, these circular, repeating patterns in the beautiful, spiritual art of a mandala. One is an application of logic, the other is an expression of beauty, but they both come from the same deep human fascination with order and perfect harmony. And believe me, the story of cyclic numbers is far from over. Their potential is still being unlocked. Right now, researchers are looking into how these principles can help AI find meaning in huge datasets, or help biologists analyze the repeating sequences in our own DNA, or help engineers design faster, more efficient algorithms. The puzzles of today are truly becoming the solutions of tomorrow. And that really brings us to this great quote from the mathematician George Cantor. In mathematics, the art of asking questions is more valuable than solving problems. A number like 142857 isn't just an answer to a math problem. It's an invitation. It's a doorway to ask deeper questions about the hidden structures that shape our entire world. It just makes you wonder, what other secrets are hiding in plain sight just waiting for us to ask the right question?